All right, today we're going to have a review of Trig, all right? The first thing is we have to talk about similar triangles. Let's do similar triangles here. I'm going to make this a right angle, and I'm going to make another one that's a little bit bigger. All right, it has a right angle. And let's say that this distance right here is 3, 4, 5, and this one right here is 10, 6, 8, all right? So because I know that this angle and this angle are the same, and these two angles are up here the same, these right here are going to be similar. Now they should have the same proportions. So and we know that this right here is a right triangle because we know that 3 squared plus 4 squared is going to equal to 5 squared. All right, it's the same thing from this one right here. This is a triplet, in fact. So we know from this ratio, so let's go from a 5 to 10. That's going to be a 5 to a 10. Should be the same thing as a 3 to a 6. 3 to a 6. And a 4 to an 8. Equals a 4 to an 8. All right? So these are similar, all right? So what we're going to be doing here is also look at this. So these triangles right here have the same proportions and everything. Now let's take a look at this portion right here from a 3 to a 4. From this triangle right here, that's going to be a 3 to a 4. This one right here is going to be a 6 to a 8, all right? That's going to be the same ratio, right? So they both equal to 3 to 4. Likewise, if I did 3 to 5 and 6 to 10, those would be equal. So that's the notion that we're going to be talking about in way of trig. Now, there are three primary functions or ratio that we want to use. First, there's the sine, and it's often it's spelled sine, but we often use sine. Okay, so I'm going to use a triangle here that I'm going to build. All right, right angle, and I'm going to call this A. All right, this is A. This is the opposite side of A. All right, this is the hypotenuse because we know that's opposite of the right angle, and we'll call this the adjacent. All right, the adjacent side. So in setting up our ratios, we use first this, let's say sine, we put over here. We've got the sine of A is going to equal to the opposite over the hypotenuse. The opposite side over the hypotenuse. And if we take a look back up here, okay, if we take a look here at sine A, on this case right here, that would have been a 6 to an 8, excuse me, a 2 a 10, all right? Which would be the same thing as 3 to 5, all right? Now, we have over here, the next one is what we call the cosine. That's what we use that. So we actually spell that S-O-I-N-E, and we abbreviate as cos, all right? So the cosine of A is going to be the adjacent over the hypotenuse. That's equal to the adjacent over the hypotenuse, all right? So if we go back and look at our situation over here, now we have A over here in this case. That would be an 8 over 10, all right? That would be an 8 to 10, which we know that we can reduce that to a 4 to a 5, all right? Now the last one is the tangent, T-A-N-G-E-N-T, and we abbreviate that as tan, all right? So the tangent of A is going to be the opposite, equal tangent of A is going to equal to the opposite over the adjacent, A, D, J, all right? And for instance, we go back over here to our friendly triangle over here, that'd be a 6 to 8, would be the tangent of this case right here, for this triangle right here, all right? Now the next thing we can do that, so we can use these ratios right here to solve a lot of problems. One of the problems that we can use for solving is that let's put together a triangle. Let's just do a triangle right here of 3. All right. All right. So if I want to put down here, let's go and put down here a 5, 3, and 4. So again, the sine is sine of A, B, C. All right. The sine of A is going to be the opposite over the hypotenuse, or 3 over 5. And the cosine of A is going to be equal to the adjacent, which is 4 over 5, and then the tan is going to be equal to the opposite over the adjacent, all right? Okay, now, so that was how we would be using to go ahead and set up what the value of the ratio is, okay? Now, the next thing we can do is find a missing side. So let's take an example of this one right here. Let's do a triangle right here, and we'll make this triangle right here. And I'm going to call this 24 degrees, and this side over here is 13. All right, this is the right angle. So I want to try to find out what the hypotenuse is. All right, so if we look at here, we know that this is dealing with the hypotenuse and the adjacent side. So therefore, we'd have to use the cosine of 24 degrees is going to equal to the adjacent 13 over x. All right, now in order to find out what x is, all we have to do is swap these two right here to make this equal to x equals 13 over cosine 24, all right, degrees.
It says Wi-Fi disconnected.
And then we go to, let's turn this guy on, all right? So now I put 13 divided by the cosine of 24, close parentheses, enter, and there's my answer. That's going to equal to 14. So this distance right here is 14, all right, 14.23, okay? So that's how we would be able to use one of these to find a missing side. But we can also do, let's try something else. What we can do is to try and find a missing angle. We can use these triangles the same way to find the missing angle. So in other words, I want to find what this angle right here is, question mark, all right? So I know this, the hypotenuse is 34, and this is 12, all right? So the way we would do this, if we look at this right here, this is the hypotenuse, this is the adjacent side, or in this case right here, we'd be using, this is the right angle, this right here would be using the cosine, -1. This is the inverse of the side, 12 over 34. And let's see if we can put that into our calculator here. So I go over here to second. Let's clear all that here. Second, cosine, you notice a -1. Then I'll put 2 divided by 34, close parentheses, enter. And that equals to 69.33 degrees. And so that would be what this angle right here would be equal to, all right? Now, let's go to, so that's how we find what the angle is, all right? We found what the ratios are, what the missing side is, and what the angles are. And there's one last thing I want to do before we end, and that's to find, let's say I'm going to draw a regular hexagon, all right? Okay, a hexagon. This probably doesn't look very regular. But in order to find, what I need to do to find the area of this hexagon, all right, is to find the area of this triangle. Remember that the area of a regular polygon is equal to 1/2 the apothem times the perimeter. Now let's make this right here 4, all right? So I've got, what is the perimeter here? I got 4 and I got 6 sides, so that's going to be, the perimeter's going to be 24. Now, I've got to find this guy right here, the apothem. This is what the A is. That's a little a, all right? Now, in order to find that, I've got to find this angle, and this angle right here is going to be half of this angle. So remember, we had that n minus 2 times 180 divided by n will give us this particular angle, all right? N being the number of sides. Well, if we put in 6 minus 2 times 180 divided by 6, that's going to equal to 120 degrees. So this right here is 120 degrees. This right, I'm going to cut in half. So this right here is 60 degrees. Since this right here has been bisected, since both of these legs are equal, this has been bisected, this is 2. So now I essentially have a triangle that looks like this. A right angle, 60 degrees. This side right here is 2. Now I have to find A. So all I have to use is the tangent now. So the tangent of 60 degrees is going to equal to A, which is the opposite over the adjacent, opposite which is A, over the adjacent, 2. So A is going to equal to 2 times the tangent of 60 degrees. And so I come back over here to my calculator and put in 2 times the tangent of 60 degrees, 60, close parentheses, enter, and there's my answer. So A is equal to let's call that 3.5, all right? So 3.5 comes over to here. Now I've got 24 times 3.5 times 1 over 2. That will go into, 2 will go into that, be 12. So all I have to do is multiply 12, clear, 1, 2, 2, times 3.5 equals, so the area of this hexagon is going to be 42, make that inches, all right, inches squared, okay? So now we have used the ratios to find we found the ratios. Remember, this the sine is going to be, this. In fact, let's do it this way. Let's remove SOHCAHTOA. The sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. So that's SOHCAHTOA, all right? And we can use that to be able to find the ratios, to find the missing side, and to find the missing angle. And remember, to find the missing side, we just use the sine of something. And to find the missing angle, we'd use the inverse of that and then put over the ratio. Okay, I hope that helps in explaining this for our quiz that we'll have on Tuesday. Bye.